to talk about what you guys do in detail. The company was founded in 2016.
2016, yep.
You personally are based in Philadelphia, but I think DBT is a globally distributed company, remote first.
We made the decision in 2018, I think, to distribute the company. So my two co-founders and I had previously worked at a company together called RJ Metrics, based in Philadelphia. We had a lot of challenges growing the engineering team at the velocity that we needed to, purely based in Philadelphia. And so we were like, we're not going to try to do that again. Really, like we've been a distributed first company for two years prior to it being cool.
Yeah. What do you guys do now? Like, this is so jumping in because I think that's a really interesting topic. Like, how do you, now that you can be back in person, like how do you guys manage that?
So I've become a disciple of the GitLab handbook. Really, like I'm sure that people will continue to use GitLab for a long time, but I think people will continue to use the GitLab handbook for like decades and decades. And so we've copied off of them from, first it was like salary bands, and now it's like in-person hybrid strategy. So we have a stipend for folks to work in co-working spaces. So Sid says distributed work does not equal work from home. So that's the same thing. We have a stipend for everybody to work outside of their home, and then we also do a lot of in-person meetups. So whether it's team level or department level or company-wide, we do once a year company-wide meetups. And it just, for the same reason we're all here tonight, like there's stuff that like Zoom doesn't do for you. I think that there are, for anybody in the audience who's used DBT, you've probably gotten the sense that it's a little bit of a different product experience than most data products you've used before. And I think that there's a lot of like counterintuitive stuff that kind of went into the beginning of it, and I think a lot of, anytime you exist inside of a community, but you decide to kind of eschew the kind of best practice conventional wisdom that it, espouses, it's actually easier to do that from the outside. And so I didn't have any friends who were like, yeah, SQL is not cool at all back in 2016, because I didn't have any friends talking about data. And so if you want to do something different, it's nice to like be on the outside of the community. So I wrote a blog post back in 2016, back when I still wrote blog posts because I couldn't find enough consulting clients to fill my day. And the title of the blog post was like, how to build a modern SaaS-based analytics stack, or something like that. And it was essentially plugged together Fivetran and Stitch, and at the time it was just Redshift and a BI tool like Mode or Looker or something like that. And the modern part of that was that you could actually this system could kind of do anything. It was in reaction to analytics products that had, if you cast your mind back to 2016, the prior generation of analytics products was like Google Analytics and Mixpanel and these kinds of like very kind of vertical specific tools that you were very constrained in the set of things that you could know about the world in this given tool. And so this was a little bit the best of both worlds. You had kind of consumer-grade experiences plugging these tools together, and yet you could ask kind of arbitrarily complex questions. There was no... The wonderful thing about it, we started as a consulting business. We were called Fishtown Analytics. And the wonderful thing about it was that I was very confident that in any conversation with a client, I could always answer the question, yes. Like, can you do this for me? And every single conversation with a business stakeholder in a data context is like, that's great, but like, can you help me understand this other thing? And the answer in the modern data stack was always yes, but it doesn't take 10 data engineers to do it. And there's nothing wrong with data engineers, but like, you like a certain amount of agility. You want to be able to turn around that answer quickly, as opposed to like spinning up an agile project to work on it.
And what it is like a journey of data from raw data into analytics. Do you want to just talk about the various steps?
It's really the original modern data stack was 4 layers. It was data ingestion. How do you get your data from all of your different upstream systems? It was data storage or warehousing, and how do you actually store and compute data? It was transformation, and then it was analytics, whether you wanted to define that as BI or notebooks or whatever. There's always been more data analysts than data engineers. There's just like, I don't know, probably 2 orders of magnitude more data analysts than data engineers. And so now that you have Redshift and you can do kind of arbitrarily complex compute inside of this like very simple infrastructure, you just kind of like show up with a SQL terminal and you can do whatever you want, that people like me are going to want to use that themselves, and not to have all of the real fun work, the data transformation, done upstream by data engineers in Scala or Python or whatever. And so there was this infrastructural shift that the cloud data warehouse represented, that really, like, you always like have an infrastructural shift, and the very first thing that happens is like you plug it into the existing paradigm. And one of my favorite examples of this is like how factories used to be laid out with this like central line, because that's how steam power used to get transmitted down the center of a factory. And it took 30 years for electrification to actually show up in productivity statistics for factories, because they actually had to lay out the factories differently. So like what happened with Redshift was that like you got data engineers who still did ETL, extract, transform, load, and they just loaded the data into Redshift. But they were still doing transformation and extraction in the same technologies that they were doing before. But the real paradigm shift for Redshift was not that you could like do the like final step differently and better. It was that you could do the whole thing differently and better. You could give the keys to the castle to the data analyst to do the whole thing. And it's again, sometimes like people get defensive, the data engineers in the audience. This is not a diatribe against data engineers. It's just that there are actually 2 orders of magnitude more human beings on the planet that can write SQL than can write Spark or Scala or whatever. So we should want to empower these humans. So ELT is really allowing data analysts to go upstream and do you extract the data from the source data systems, you load it into originally Redshift, but now Snowflake and BigQuery and et cetera. And then you transform it once it's there, and you transform it in SQL.
Still, in an effort to make this interesting for everyone, do you want to explain what data transformation actually is? Like a couple of examples, like 2 minutes.
So my favorite my favorite example of what data transformation is that we worked for a grocery delivery company. And one of the most challenging problems that this company experienced was that they needed to calculate cost of goods sold for their orders. And cost of goods sold, every order was different, so the cost of goods sold needed to be able to go down to the individual product SKU level. So like you needed to say, what's the COGS for one of those little bunches of green onions? And like it turns out that calculating the cost of goods sold for like a bunch of green onions was tremendously complicated. It like you relied on all this inputting cost data and how big were the bunches and all this stuff. And so this group of 3 or 4 of us would have these long conversations about what does it mean, like what does that even mean, cost of goods sold for green onions. And you then eventually get to a place where you've kind of sorted that out. You've defined what that means, and you save all that knowledge into one table or a small number of tables. And then literally nobody else at the business has to ever think about that again. Like that's this really tremendously annoying problem that thankfully a small group of people can solve. And then if you've documented it well and you've like done your modeling well, everybody else can just kind of consume. So data transformation is really this process of like taking this raw data and applying business context to it and creating these curated data sets that the rest of the organization can use as interfaces to the data or the knowledge at the organization without having to like literally build up an understanding of how every single business process works from the ground up in order to be able to do like literally any analysis at all.
And obviously a lot of the excitement around DBT from a market and investment perspective has been that DBT Labs, the company, and DBT Core, I guess the project, has owned this transformation layer. Do you want to explain what DBT actually is and what it does?
DBT is the T in ELT. I was just talking about how this re-architecture. So DBT does not ingest data into your warehouse. It transforms it once it's in your warehouse. The funny thing about that is that if the data is already in the warehouse, then the only thing that you need to do to transform that data is write SQL. And you can do that in a couple different ways. You can like create a view that abstracts some business logic, or you can create a table that stores the results of a query, or you can incrementally update the data in a certain table. But what DBT does is it allows data analysts, analytics engineers, data engineers to write these small bits of logic, modular business concepts, and slowly build up a directed acyclic graph, a DAG, of these concepts. And you go from left to right, and you start at the source data, and you slowly build up all of these concepts where you eventually get to a place where you're dealing with business concepts that can be productively analyzed. And DBT is the framework that allows you to both like express all of that in code, but then also to run it against your database and like materialize all that stuff.
I read or heard somewhere that one way of thinking about it is an abstraction layer comparable to Rails, where instead of like writing a bunch of things, you can just write 1 or 2 lines, and through DBT you end up very richly expressing what you meant.
Yeah, we many of our careers, and myself included, did not go back to like the 90s when people still like wrote every web application in like raw HTML. But like that's where internet programming started out. Like you wrote every single line by hand, and then you got web frameworks. And once you got web frameworks, you were never going to go back. It's not like you were ever going to throw away the framework because it cut down the number of lines of code you had to write by, I don't know, 75% more. Like it's a tremendous like increase in abstraction and increase in productivity. And so I really think that, you look at the launch of Airflow in 2015, I think it was 2015, and it was this great kind of it was just like, here's a way to run a bunch of code on a schedule. And like, well, what code? And the answer was like, well, any code. And so people just started writing the equivalent of like raw HTML. And that is fine, but it's very low leverage. And so DBT is an attempt to start like moving us like up this abstraction level. And as a profession, like data is generally probably 2 decades behind software engineering in terms of like the productivity of practitioners and the level of abstraction and everything. I wrote in 2016 this blog post that was how to build a mature analytics workflow. And it was essentially saying like all of these practices that have been matured over decades in software engineering, we just need to like replicate them over into data, deployment processes and testing and like all of these different things. And like the whole concept that like you should work on documents that are or documentation that is kind of native, inbuilt into the code so that it doesn't get out of date and all of this stuff. This was a novel concept. Like back in 2016, the like data practitioners were sending each other SQL files as attachments to emails, and that was like the way that we worked together. And early stage VCs that I spoke to back in 2016 told me that like it wasn't at all clear that data practitioners actually wanted to learn Git. Like that, it wasn't, DBT was kind of a non-starter because it wasn't clear that data people wanted to use Git. Fortunately, there has been this explosion of data tooling companies that especially over the past 2 years, that do more and more of this stuff. It, honestly, at the beginning, it felt like we were going to have to do all of it, which is why you see us do documentation and testing and deployment and everything. But it's actually been wonderful. Originally, it was a little bit threatening because, like, oh my gosh, how are we going to fit into this new, ever more crowded ecosystem? But eventually, it's been wonderful to have new folks like join this party and realize that like it's going to require an entire ecosystem of vendors to like recreate this kind of software engineering mindset.
Sure. And so DBT for a long time still is, but was originally a very popular open source project that you built. I think you started RJ Metrics while you were consulting, I think the Fishtown Analytics, which morphed into DBT Labs, was a consulting company. So it's a popular open source project. You're now a super well-funded startup, and there is now a product called DBT Cloud, which is the, I guess, commercialization effort around DBT. What does that do, and how do you think about it versus the open source project?
The original thing that DBT Core did was it provided a language to express data transformations, and it provided a command line interface to actually execute them. We were out in the world actually doing consulting projects. So I was, the backstory with me and venture funding was that I had worked, prior to starting Fishtown Analytics, I had worked for 7 years in 3 different VC-backed companies. I don't know if any of you work at VC-backed companies, but it can be a reasonably high burnout environment. So I was a little bit burned out, and I was like, no external capital, no external expectations. I'm going to fund this on revenue. And so we did that for 3.5 years. We were like paid the bills via consulting. We like at the time, the only thing that existed was DBT Core, and we clearly needed a way to operationalize this. As we're like working with clients, we've got all these great jobs described, but you need to actually like update data on whether it's 4 hours or once an hour. It's not twice every second. And so that was like, we originally called it Sinter. We didn't even anticipate that it was going to be like an associated commercial product. But it got more and more users over time. And what we've realized is that DBT Core presents this like wonderfully concise surface area for an open source project. It allows you to describe what should be true about your data. It's stateless. You write code in it. It kind of functions as a compiler. And then DBT Cloud is like how you actually make that stuff true in reality. It includes a scheduler. It includes a metadata API to actually ask what is true about your production systems today. It includes an IDE to actually help you author this stuff. But this divide between like describe your data pipelines in code versus like actually help me manifest them in reality is the core cloud split. The classic problem is, any organization of sufficient size has multiple different ways to analyze data. You'll never get rid of spreadsheets. You will always have some kind of BI tool or multiple BI tools. You will probably have a notebook experience. You will always have like multiple of these ways of analyzing data. And some of them have no governance layer at all. Some of them have a governance layer that's like bespoke to that particular tool. And so there's this real need to like take the governance, like we were talking about with green onions, the cost of goods sold. There's like, what is revenue? What is orders? What is like all of these business concepts? And so there's this desire to push that upstream to DBT. And it turns out that like just the way that I was talking about before, how data transformation in a data warehouse context is just like writing SQL. Defining metrics is just writing SQL. And so what DBT is doing is it's taking all of this ability to write SQL really effectively with leverage, and it's exposing that in an interactive context. So we've always been good at this batch-based context. Now we're building an interactive context where a user in a BI tool or in a notebook or wherever can say like, hey, I want revenue. And I don't actually know how to write the SQL to get revenue. I'm just going to ask you for revenue. What DBT is going to do is it's going to actually rewrite that query. It's going to get the canonical definition of revenue. It's going to execute that against the warehouse and then bring the result set back. And that layer is going to sit in between the BI tool and the data warehouse for all those different BI tools so that you can present a consistent view of those metrics to every user.
So where do your ambitions start and stop in terms of like roadmap for the next couple of years?
The thing that is neat about the position that we're in right now is that we get to ask the question like, how should all this stuff work? Not like, what is the one piece that we can build, but like, oh gosh, we actually have a lot of people using this thing, and that gives us an opportunity to say like, let's build something that maybe no one's actually been able to build before. One of the nice things about DBT is that it allows you to create this map that spans the entire graph of computation inside of an organization, from like the data landing in the warehouse all the way through to like people using the data on the other side. But DBT actually understands like, hey, this is a data source. This data is coming from Fivetran. And then it knows this is a data transformation. It's executing on Snowflake. Or this is a Python-based data transformation. It's executing on Databricks. And then here is a Looker dashboard that's querying this table, et cetera. And so anybody in the data ecosystem that's building a product or like in-house tooling can query this API and say like, hey, tell me the state of my data. You can ask questions like, is this data source outdated, or does this data source, or does this transformation power a downstream dashboard? So one of the things that most of the practitioner space in the DBT community doesn't actually understand is that the DBT Cloud API is now powering like dozens and dozens of partner applications, because it turns out this knowledge is really, really critical. As we move forwards, we're not looking to like own cataloging or own whatever, these different categories. We're looking to be the infrastructure that powers this ecosystem, because it turns out that you don't actually want to connect to like 4 different competitive metadata API. You just want to plug into where all that knowledge sits. There's no way in the world that Apple was going to build every experience on the iPhone, but they had to build some of the foundational ones and the APIs such that this like innovation ecosystem could bloom. If you didn't have the App Store, then all of the downstream innovation wouldn't have happened, because you actually need to get people to a place where the amount of work that needs to be done to create an app is like constrained enough such that like it can be economically done by enough vendors. So our goal is actually to continue to make it easier and easier to like innovate and solve these problems, and we're helping to build APIs to make that happen.
Okay, great. All right, some questions, and I know you literally have a train to take, so we'll keep if we have questions.
I get the impression that DBT is pushing the idea of SQL first when you think about how you write your data transformations, which feels at odds with trying to build abstraction layers on top of SQL, because with DBT you're still you compile your SQL and you hope it's valid code that runs against your warehouse.
Okay. We've become very well identified with like SQL maximalism, and that's not actually the point of view. The point of view is like one, the persona that we care so much about primarily speaks SQL, and 2, we really believe in bringing the code to the data and not the data to the code. And the data environment that we started in was like the data warehouse, and so that was an environment that spoke SQL. Now, data warehouses are now moving towards supporting multiple languages. We really do think that the the future of data processing is polyglot, and I think that if you look in 5 years, you will find more robust abstractions on top of data, and even in the DBT ecosystem, than SQL. That's not me like making product roadmap statements, but like I think that that's the direction that things are moving in.
What workflows should people not use the modern data stack for?
Right now, what is typically known as the modern data stack, you would be correct in saying that is not that well identified with the machine learning data science part of the world. And I think that that's for a bunch of historical reasons that don't necessarily have to be true in the future. But I think legitimately, if you look at the main processing platforms of today inside of the modern data stack, they have their roots in data warehousing and not in ML. And so it will take some work to like plug these things together. Again, if you look in 5 years, I think that this distinction will have been sanded over and will not be salient anymore. But I think that today that's still roughly true.
All right, are we calling this a wrap? All right, thank you so much. I really appreciate it.